Is it visible to all?
Yes, sir.
Okay, thank you.
Okay, thank you. So the power quality, what is the power quality? As we discussed about you know about the food quality, and you are moving towards the very good food, uncontaminated food, and uncontaminated water, air. Then similarly, which parameter decides the power quality? So we can define, as you know, that the power means multiplication, or it is the multiplication of the voltage and current. Is simply the product of the voltage and current. Okay? So if we multiply the current and voltage, we can get the power. Simply you can say the DC power, or VI cos phi is the AC power. So power means two parameters, voltage and current. So the voltage and which quantity is important for the power quality. Actually, voltage is more important for the power quality point of view. So any change in the voltage or current or frequency that interferes with the normal operation of the electrical equipment is known as the power quality disturbance or power quality issues. Okay. So any parameters that interferes with the voltage, current, or frequency that affects the normal operation of the electrical equipment. So this is known as the power quality. So what is the cause of for the example of this power quality is you might have experienced, we all experience the power cut. So power cut is in technical terms it is known as the long term interruption or short term interruption. So this is a power quality disturbance, and over voltage and under voltage are also the power quality disturbances. So these all are the power quality disturbances, and this is come into one umbrella. All these disturbances bundled in under one umbrella known as the power quality disturbances. And what are the different cause of the poor power quality or power quality disturbances? The main parameter is nonlinear load. Now we are, as I said earlier, that we are moving towards the using of more and more semiconductor materials. So that means we are using more and more non-linear loads. So use of the non-linear loads, electronic equipments, computer-based, automatic and smart devices leads to the bad power quality or power quality problems. Another main important issue is using or rapid integration of the non-conventional energy sources into the grid network. As we know, nowadays we are integrating the solar power stations or solar power distributed generation into the grid. So it may also create a new problem, and this problem is known as the power quality. Maybe the harmonics, maybe the under voltage, over voltage, maybe the any other problems, power factor problem, and all other problems we are facing. And also the harmonics is also a very important power quality issue, and because of that harmonics, the misoperation of the devices may be so now how to classify these power quality disturbances, power quality issues, or power quality problems? It is synonyms in the literature. In the literature, power quality problem, power quality disturbances, and power quality issues are same. So it can be classified as per the standard IEEE 1159 to 1995 standard generally. So in the literature, we study generally we study or follow this type of the standard to classify all the power quality issues. And this power quality can be, or power quality disturbances can be classify based on generally the duration and magnitude of the voltage. Three categories may be there. This is they define the power quality disturbances. Duration and magnitude. Duration and magnitude will decide the or can be classify the power quality disturbances. How to classify? Duration can be classified from 0 to 0.5 cycle. This is known as the very less duration, instantaneous. 0.5 cycle to 1 minute. This is the short duration power quality disturbances. In this gap, it is known as the short duration power quality disturbance. And above, if any power quality disturbance remains for the duration more than 1 minute, it is known as the long duration power quality disturbance. So broadly, we can classify this on the basis of duration is the transient type and short duration type and long duration type. So in this transient type or very less means less than 0.5 cycles, it is known as the transient. And short duration in the short duration 0.5 cycle to the 1 minute, we have the power quality like the sag and swell. Sag means voltage dip or lesser the voltage. This is our normal band of the voltage. Means 100% is the nominal voltage and 100 to 90% voltage or 0.9 per unit or 0.9 per unit to 1.1 per unit voltage level falls under this band, or it may be known as the normal band. And below this, this is a problem. Above this, it is a problem. So below this, it is called the sag. Okay, means this 0.9 per unit to 0.1 per unit. So 0.9 per unit to 0.1, if voltage falls 0.9 per unit to 0.1 per unit for this duration, for a 0.5 cycle to 1 minute, it is known as the sag. Similarly, swells means if the voltage falls above or becomes above the 1.1 per unit or approximately up to the 1.8 per unit for a duration of 0.5 cycle to 1 minute, it is known as the swell. Now similarly, over voltage and under voltage, the same definition is there, but the difference is for the duration. If more than one duration, if the sag means voltage dip remains more than 1 minute, then it is known as the under voltage. And if it is for we can, I think we should take then, so it will be more easier.
अरे बहन जो चूतिया
Sir, you can open whiteboard from option.
Okay. Whiteboard
three, but
we can open, but we can write on this also.
Yes. Right click and pointer option.
Okay. So the power quality, this is the sag, swells, over voltage, under voltage, and now comes to the interest. If our voltage falls under this segment, this here 0.5 cycle to 1 minute, and below 0.1 per unit, or then it is known as the short term interruption. And if it is more than 1 minute, it is known as the long term interruption. And some special type of the power quality disturbances are also there, which is known as the voltage, which is not defined from this characteristics. It will be defined later on. Okay. So come to this. So most of the power qualities, transient, sag, swell, over voltage, under voltage, and interruptions can be defined from this curve and it is very important given by the IEEE 11592 1995. So if we come to the transient may be the impulsive transient and may be the oscillatory transient, because most of the now the most participants are from academics, so it is very important to know about the transient. So it is, you know about the transient, it is the variation of the voltage for a very less duration, okay, and for very high voltage for a very less duration, known as the transient. It may be the impulsive or it may be the oscillatory. Means impulsive transient means what is the region of impulsive transient? That is the lightning, or it also known as the lightning transient, or it may be as the switching transient. So, over voltage, transient over voltage in the electrical engineering can be classified as the lightning over voltage or switching over voltage. So, lightning over voltage means due to the lightning, and switching over voltage means due to the switching of operation of the circuit breaker. So, these are the transients. What are the main cause of the transient? So, main cause of the transient, as we know as the name, lightning and switching. So, this is the lightning and switching are the main cause of the transient. So, we have also discussed the sag. What is the sag? So, simply we have discussed the sag. This is the less than 1 minute duration voltage dip, known as the sag. So, what is the cause of sag? The cause of sag and swells are fault. Generally, fault is the main cause of the sag, and sudden connection of the heavy load may also lead to the sag. What is the impact of this sag? This sag may shut down various equipment due to tripping of the contactors and the electromechanical relays. This sag is very important as there is a very huge loss in terms of money is occurring in every year in every country, in our country also. The swells is also, it is the increment of the voltage greater than 1.1 per unit, okay, for a duration less than 1 minute, 0.5 cycle to the 1 minute. So again, the cause of this swells is also fault, and also switching off a large load, energizing a large capacitor is also a cause of this. Now, integration of distributed generators or distributed generations in the grid is also this cause, because sometimes if we shut down that distributed generation, then suddenly our voltage will shoot up. And what is the consequences of this high voltage for a shorter duration is the data errors, semiconductor damage in electronics devices, insulation degradation, flickering of lighting devices, and visual screens. Now come to the over voltage. Over voltage and under voltages are very known phenomena, and we know very well these two phenomena. Over voltage is an increase in the RMS value. Keep in mind it is the RMS value, not the peak value. RMS AC voltage greater than 1.1 per unit or 1 to 110% of the power at the power frequency, okay, for a duration greater than 1. So, what is the cause of this long duration power quality disturbances? The mainly that is the shorter duration power quality disturbances. The mainly cause are the fault, and here the mainly cause of the switching of the heavy loads. Load switching is the mainly cause. So you can just remember the things that what is the cause of different power qualities. Yeah. Incorrect tap setting on the transformer is also the cause. Consequences are the flickering of light device screen or stoppage damage of the sensitive equipment. If you have any question or query in your mind, you can just type in chat box so that we can discuss later on. Okay. Now come to the under voltage. An under voltage is a decrease in the RMS AC voltage to less than 0.1 unit or zero point 0.1 unit up to the 0.1 per unit at the power frequency for a duration longer than 1 minute. And under than 1 minute, it is known as the SAG. If longer than 1 minute, it is known as the under voltage. So it is very. So again, cause are the switching of the heavy load, switching of capacitor banks, and integration of the distributed generation. And also impact is the increasement in the loss of electromechanical devices. This is very important that under voltage, due to that under voltage problem, a losses of the in the electromechanical or induction motors, mainly because 80% of the motors are used. 80% of the motors are used as an induction motor in the industry. So because of the lower of the voltage, to have the same power draws more current and more losses. And also torque and speed reduction is also there. So degradation of the quality of product is also. And for the day-to-day life or domestic users, a lower voltage is also having the problem or means refuse to blow the tube light. Now because now the tube light is smart now, because of the we are using the LED tube light, so it blows even the lesser load. So now it becomes not a big problem. Now the another very important power quality issue is the voltage imbalance or imbalance. So I did my PhD on this only power quality problem. I did my PhD on this topic, voltage imbalance, the effects of the voltage imbalance on the performance of induction motor. So I investigated various voltage imbalance conditions and all these things, and how to define the voltage unbalance factor, and much more. If anybody interested to discuss later on from my research or voltage imbalance, unbalance, voltage sag, and all other things to go inside, then he or she may discuss to me later on. I will share my email address and contact you. So this voltage imbalance is and the main thing is the our government or government agencies are not still paying the attention of this voltage imbalance regulations in India. So what is the voltage? Let us discuss what is the voltage imbalance or unbalance. Somewhere in literature it is known as the imbalance is written imbalance, or somewhere it is written unbalance, voltage unbalance. So what is the definition of the voltage imbalance or unbalance? If the magnitude of all phases are not equal, as we know, as the three-phase power should have the equal magnitude and equal phase difference of 120 degrees. If it is not so, then it is known as the voltage unbalance or voltage imbalance problem. If the magnitude are not equal, is known again, it is the voltage unbalance. If magnitude are equal and phase angle are not 120 degrees, again it is a problem of voltage. A mixture of these two, it is again a hybrid type of the voltage unbalance problem. So voltage unbalance generally is quantified by a factor known as the voltage unbalance factor, VUF. And the VUF is just given by 3 agencies as per the NEMA standard. As per the NEMA standard, VUF, voltage unbalance factor, is the ratio of the maximum deviation to the average. Maximum deviation to the average. Or what is the maximum deviation? Means maximum deviation from the average. So it is the maximum first phase deviation of the average voltage, take the second phase, Third phase, what is the maximum deviation? We'll take the numerator and write the denominator. Average voltage multiplied by 100 will give you the voltage unbalance factor in percentage. As per the IEC definition, it is the ratio of magnitude of negative sequence to the positive sequence voltage expressed in percent. It is nearly similar to that definition, because negative sequence voltage, what is the negative sequence voltage? You know that sequence of the voltage means whenever the three-phase supply becomes unbalanced, then as per the theorem, then we can decompose this unbalanced supply into three balanced supplies known as the negative sequence, positive sequence, and zero sequence. Okay, so this is the negative sequence arise because of the unbalance. So that numerator is the this is the maximum deviation. It is merely we can equate to the negative sequence voltage. It is the magnitude of the negative sequence voltage, not the angle. But nowadays, or some researchers are also using complex VUF, known as the complex VUF. It is taken the magnitude as well as the. So this is all about the voltage unbalance factor. It's very important related to the voltage unbalance. What is the cause of this voltage unbalance? Large single phase load. Okay. Incorrect distribution of a single phase. Mainly the main cause of this is the incorrect distribution of the single phase load, or fault. If fault occurs in a single one phase, then the supply can be restored from the other phase. So it may also be a cause of the voltage unbalance. What is the consequence of this voltage unbalance problem? Because voltage unbalance exists in distribution network always. The perfect balancing of the voltage is not there. So that's why the excess loss in the electromechanical devices will lead to reduced efficiency. Means three-phase device. We are talking the three-phase device. And torque and speed pulsation is another very important consequence, and which requires more research in this area. What is the impact of the voltage unbalance in the speed and torque pulses or mechanical damage of the shaft? So I did my observation using the MATLAB on this, how it impacts the torque and speed pulsation or mechanical damage to the shaft. It also reduces the torque and speed, which affect the quality of product, and also it may lead to fail the equipment to start. Now another problem is the voltage, special type of the problem which cannot be defined by that. It is a voltage fluctuations. So the voltage fluctuations or flickers, it is also a day-to-day language. Flickers is known as this. The voltage fluctuation is a systematic variation of the voltage waveform or a series of random voltage changing of a small dimension, namely 95 to 105% of a nominal at a low frequency, so that it can be visible from our eyes. We can perceive these changes, known as the voltage fluctuation, and it is continuous in nature. The main cause of this, it is the arc furnaces or any other semiconductor loads. And consequences are the flickering of light devices, screens, TV screens, giving the impression of unsteadiness of visual perception, and it also affects the bad quality of our product. Now another very important power quality event. It is also one disturbance is also known as the event. Generally, it is known as the disturbance, and that swells, short-term disturbances are also known as the event, power quality event. So there are various terms used by the researcher and literature. Now come to the waveform distortion. Waveform distortion is defined as the steady state deviation from an ideal sine wave of the power frequency principally characterized by the spectral content of the deviation. Means we know that the our power is having the sinusoidal wave, perfect sinusoidal. If there is any deviation in that sinusoidal waveform, then it is known as the waveform. So in that waveform distortion, 5 subcategories are there: harmonic, DC offset, interharmonic, notching, and noise. And most important in this is the harmonic. So we'll take in this session only harmonic. So that harmonics means our waveform is deviates from the sinusoidal. It becomes somewhere non-sinusoidal. So in non-sinusoidal type, what period? In non-sinusoidal type waveform, which can be represented as a sum of different sine waves with different magnitude and phase having the frequencies that are multiple of power system frequencies. And these components are known as the harmonic. Means what does it mean? Means a simple non-sinusoidal waveform or contaminated waveform. If the waveform is not pure sinusoidal, then a unpure or non-sinusoidal waveform can be decomposed into various sinusoidal waveforms having the integral frequency or multiple frequency. Having the multiple frequency, what multiple? Multiple of 50. Means first harmonic means 50 hertz frequency. Same for fundamental, it is also known as the fundamental harmonic. Zero harmonics is also there. This is the DC offset or DC voltage is known as the zero harmonic. DC voltage is present means if there is zero is not at center, then voltage. So harmonics, what is the harmonics? So this multiple waveforms, decomposed waveforms is known as the harmonics. So first harmonics is the fundamental harmonic, 50 Hz frequency. Second harmonics, 100 Hz frequency. Third harmonics, 150 frequency, having the different magnitude, but lesser than the fundamental harmonic. And different phase. So these components are called the harmonics. So most commonly used indices for measuring the harmonic content of the waveform is known as the total harmonic distortion, known as the wave. And it can be measured as the THD measurement or power analyzer. So THD can be defined as root of the, if voltage is there, so M in place of the M we can write the V. So it should be started from 2. H must be greater than 1 because first harmonics is fundamental. So THD is from the second harmonic. So V2 square, root of the V2 square plus V3 plus V4 plus V5 square divided by V1 divided by the fundamental. So it is the formula for calculation of the THD. So but it is important to note here that in this Fourier series, this analysis of this sinusoidal, non-sinusoidal waveform is done by using the Fourier series, as electronics people or electrical people are doing in this course, circuit theory and analysis. So if it is the harmonics may be the even harmonics or odd harmonics. Okay. So even harmonics and odd harmonics. Odd harmonics means first means the fundamental, first, third, okay, fifth, seventh are the odd harmonics. Even harmonics, second, fourth, sixth are the even harmonics. Okay. If the positive half and negative half is same value or it has the same magnitude, then odd harmonic, generally the theorem from the theorem, the odd harmonic, even harmonics is absent. So only odd harmonics are there for this sinusoidal waveform or our power network. So in our power network, generally odd harmonics are present. Means from the third harmonics, third, fifth, seventh. What are the causes of these harmonics? So the causes of these two types of the causes are there. The earlier or causes, or conventional causes, are the electrical machines working above the magnetization curve means saturation, arc furnaces, welding machines, rectifiers, and DC. So these are our conventional sources of the harmony. Now, due to the use of various materials or various devices, so these are the non-linear loads. So we are using now non-linear loads. So all types of the non-linear load in the domestic applications, we also are using the non-linear load. In our house, we have the LEDs. So LEDs is a very bad load, or it is also known as the, you can say these all non-linear loads that creates the problem or integrates the harmonics into the system are also known as the dirty loads. So now we have replaced our all lighting system in the LED lighting, in shops, commercial, everywhere we are using the LED lighting, and it creates a new type of the problem, integration of more and more harmonics into the system. So again, it is a research area where we can impact on our grid of integration of these small LED lights and the inverters. So what is the consequence of this harmonics? This harmonics may lead to losses of all electrical equipments, failure of protective relays, and error in measurement. Now, error in measurement means now we are going to measure the power factor, false power factor. Okay. So this is we have now meters, smart meter available with us as a true meter, which gives the true RMS. What is mean of the true power factor? One is the true power factor, one is the displaced part of power factor. So true power factor means actual power factor. Means considering the harmonics, we can calculate the power factor. Okay. So this is the kilowatt divided by kVA. Kilowatt when harmonics are present and kVA when harmonics are present. So it is measured by a 2 meter, known as the true power factor meter, true voltage, current, all this. So incorrect measurement is also there. Now then next is the interruptions. Interruptions is very well known from earlier. Long-term interruptions, you might have experienced the long-term interruptions. In villages, there is a very good example of the interruptions. They are very used to interruptions for a very longer time. It means longer than 12 hours. So an interruption is a condition in which voltage at the supply terminal is close to zero. Means it is almost zero. If it is lesser than 1 minute, it is known as the short-term interruption. If it is longer than 1 minute, it is known as the sustained interruption. So what does mean is the sustained interruptions? That meaning some human intervention is required. Some fault is there. Or maybe the intentionally power cut is there. And human intervention is required for the to restore the supply. For short-term interruptions, if a fault occurs and self-clearing fault are there, like lightning, or if lightning is there, then it may be taken less than 1 minute. So a circuit breaker, auto close circuit breaker may create of these type short interruptions. So it is automatically restored. Now, third, it is the power quality mitigations. Excuse me, और ज़्यादा आ रहा है, थोड़ा मैं बंद कर देता हूँ. Okay. So till now we have discussed the various power quality issues. Now we'll discuss what are the methods and devices to mitigate different power quality problems. Okay. So if we are discussing from my side only, it may be a case of some boring. So can we share can we share your knowledge about the power quality mitigation techniques you are, because we all are using somewhere in domestic and user also. So which devices you are using to mitigate the power quality problems? Any example, any if you have any experience of using these devices, anyone? कोई इसमें से बता सकता है? कोई भी कौन सी डिवाइस आप लोग यूज कर रहे हैं? कोई डिवाइस आपने मिटिगेशन डिवाइसेस के नाम आपने देखे हैं तो यू कैन शेयर. एनीबडी कोई शेयर करना चाहेगा? देखिए यूपीएस वी ऑल हैव द यूपीएस, अनइंटरप्टेड पावर सप्लाई. ये कंप्यूटर के लिए यूज होता है. वी नो दैट यूपीएस, वी आर यूजिंग द यूपीएस. हर घर में यूपीएस है. अप्रोक्सीमेटली यू हैव द इन्वर्टर. इन्वर्टर इज ऑल्सो देयर. तो ये दोनों ही तो पावर क्वालिटी मिटिगेशन डिवाइसेस हैं. So we'll discuss now what are the different mitigation devices. Okay. So this is the PQ mitigation. देखिए G1, G2, G3 means first generation devices, second generation devices and the third generation devices. थोड़ा सा ओवरव्यू देंगे क्योंकि देखिए पावर क्वालिटी इज ए वेरी वेरी ब्रॉड टॉपिक. पावर क्वालिटी इशू अलग है, फिर द इम्पैक्ट ऑफ दैट पावर क्वालिटी इज अनदर वेरी इंपॉर्टेंट टॉपिक. अब पावर क्वालिटीज के बहुत सारे डिस्टर्बेंसेस हैं, बहुत सारी इवेंट्स है. हर एक इवेंट इस तरीके से इम्पैक्ट करेगी, कहाँ पर, मशीन पर, ग्रिड पर, आपका इन द डिस्ट्रीब्यूशन नेटवर्क, इन पर्टिकुलर machines, in particular transformer, induction motor, all these things. So this is all area of study. So power quality is very very broad. So this is just a overview of this all the power qualities. So how to mitigate? So first is the generally we have discussed all type of the power quality problem. That is the harmonics, sag, swells, under voltage, over voltage, okay, unbalancing, all these. So it can be mitigated by devices like in first generation only we are more concerned about the harmonics. Okay, so to reduce the harmonics we have the filters, passive power filters, then active power filters come into picture. Okay, then we used the hybrid filters to mitigate the harmonics and power factor. So nowadays research is also researchers are also doing work in this hybrid type of the filters, various filters, hybrid type of the filters with multiple tasks. Now in second generation we are more concerned about the voltage regulations and filters and all other power quality disturbances. UPS is well known to us. It mitigates the interruption. Power cut हो गया, then we can have the power supply without any intervention. Computer चल रहा है, चल जाएगा. Under voltage, over voltage, and all other online UPS. Actually, UPS have the three types: the online UPS, offline UPS, and hybrid UPS. Online UPS is most important for the power quality point of view. Your offline UPS will work whenever only for the interruption. ठीक है, तो यूपीएस मीन्स टू टाइप्स एट लीस्ट ऑफ दिस। ऑनलाइन यूपीएस है, देन इट विल वर्क फॉर ऑल टाइप ऑफ द पावर क्वालिटी। ऑफलाइन यूपीएस है, एंड इट विल वर्क ओनली फॉर द इंटरप्शन। तो ऑफलाइन यूपीएस और ऑनलाइन यूपीएस में क्या डिफरेंस है? व्हाट इज द डिफरेंस? ओनली द डिफरेंस इन ऑनलाइन यूपीएस इट सप्लाई द पावर एज स्टेडी स्टेट, मींस फ्रॉम दिस बैटरी इनसाइड दैट। ऑफलाइन यूपीएस में क्या है? इट सप्लाई द पावर फ्रॉम दिस यूटिलिटी until the power interruption occurs. Similarly, in generation 2, the static voltage compensator, distributed state-com, and are also come into picture. And when one another device known as the dynamic voltage restorator (DVR) voltage, so is also very good or very important device to mitigate the unbalancing and सैग और अनबैलेंसिंग की जो भी प्रॉब्लम थी उसको डीवीआर। अब हर एक डिवाइस पे आप स्टडी अलग से कर सकते हैं। सो वेरियस डिवाइसेस नोन एज द फैक्ट डिवाइसेस आर आल्सो। देन इन द जी3 क्या है? जी3 एक ही डिवाइस से कई काम कर देते हैं। यूपीएफसी एंड यूपीक्यूसी मींस दीज आर वेरी वास्ट डिवाइसेस। It can use for every type of the, it can mitigate the sag, it can mitigate the unbalancing, it can mitigate the voltage regulation also, frequency voltage. So all type of the mitigations or all type of the power quality problems can be handled by this type of the devices. So research is going on still on this UPFC and UPQC, uninterrupted unified power quality conditioner. This multifunctional DGs are also come in this picture. Multifunctional distributed generation. Now it is DG is very important term nowadays because distributed generation are the cause for the poor power quality. And one another I would like to share you that the devices which are mitigator for the power quality can also producer of this somewhat produce also the disturbance. जैसे आप मान लीजिए कि कोई आपको प्रॉब्लम है, ठीक है, कोई इन्फेक्शन हो गया, then you take the medicine, ठीक है, एंटीबायोटिक मेडिसिन, तो उसका भी तो अपना एक साइड इफेक्ट है। इसी तरीके से डिवाइसेस का भी है। कोई भी डिवाइस आप यूज करेंगे तो ये ठीक है, इट कैन मिटिगेट सम पावर क्वालिटी प्रॉब्लम, लेकिन इसका भी अपना कुछ ना कुछ इफेक्ट। Then again, we are currently discussing about the research scope, but this research scope in this area can be broadly classified as impact analysis and mitigation analysis. So impact में तो power quality impact of on different devices can be done. Research on can be done on different devices and protection devices. Protection devices क्योंकि misoperation or maloperation of the protection devices is there due to the harms. अब various power quality जैसे some researchers have taken one power quality, you can take multiple simultaneously power quality, क्योंकि हार्मोनिक्स होगा ही होगा, साथ में अनबैलेंसिंग भी होगा, साथ में अंडर वोल्टेज भी होगा, ये सारा के सारा एक ही साथ रहता है, अलग अलग नहीं रहता। तो प्रैक्टिकली इट इज सिमल्टेनियसली, तो आप उसमें रिसर्च कर सकते हैं। आई डिड दिस टेकिंग द मल्टीपल पीक्यू सिमल्टेनियसली पावर क्वालिटी, हमने 3 लगभग एक साथ लिए हैं। मैकेनिकल इम्पैक्ट मींस वाइब्रेशन एनालिसिस, शाफ्ट का लाइफ की प्रॉब्लम है, वो सब आप कर सकते हैं। पीक्यू मिटिगेशन डिवाइसेस पे काम कर सकते हैं, फिल्टर्स पे समय एक्टिव पावर फिल्टर्स, पैसिव पावर फिल्टर्स and the combination of this active and passive combination of series and parallel. So all these filters research are going on the filters. Filter is a very vast topic. अपने आप में एक टॉपिक है, एक अलग बुक है फिल्टर की, कई बुक्स अवेलेबल हैं, तो उसमें से आप पढ़ सकते हैं, फिल्टर्स पे भी काम कर सकते हैं। Another area is for the converters. कन्वर्टर्स पे भी आप काम कर सकते हैं। मल्टी लेयर कन्वर्टर्स, मल्टी लेयर इन्वर्टर्स, यूपीक्यूसी, डीवीआर एंड वेरियस फैक्ट डिवाइसेस, इस पर भी काम कर सकते हैं। एंड आर्टिफिशियल इंटेलिजेंस एप्लीकेशन फॉर दिस स्मार्ट ग्रिड and micro grid distributed generation can also be applied. तो मल्टी लेवल इन्वर्टर्स काफी लोग काम कर रहे हैं. So you can do the work for the multi level inverter. Various algorithms are there to control, various control strategies are there. Micro grid पर भी काम कर सकते हैं. ये इसके लिए भी जरूरी नहीं है कि आप रिसर्च करें. You can also write the papers on these topics. These topics are very good topics, that multi-level inverters, microgrid, distributed generations, and as far as the UG and PG students, you can deliver the seminar. You can take the topic from these types of these, like this distributed generation, microgrid, smart grid, multi-level inverters, multifunctional distributed generators. So various topics are there, UPQC, DVR, fact devices. Okay, तो बहुत सारे topics हैं, यहाँ से आप लोग ले सकते हैं. Now come to the power quality regulation in India. What about the status of power quality regulation? हमारे यहाँ हालांकि देखिए power quality issues बहुत ज्यादा है. We are delivering we are discussing about the power quality. 2 बार मेरे यहाँ लाइट जाती है, तो यूपीएस नहीं होता, then it will be difficult to deliver this. ठीक है, तो वोल्टेज देखिए +6 to -6, एचटी साइड में +6 to -9, हार्मोनिक्स आपका TDH 5%. इट इज PQ regulation. Actually working agencies have forum of regulators, Asia Power Quality Initiative, different PQ working groups. Okay, बहुत सारे वर्किंग ग्रुप्स हैं, SERC है, और सेंट्रल CEA है, और सेंट्रल इलेक्ट्रिसिटी अथॉरिटी, और कमीशंस हैं स्टेट एंड सेंट्रल. तो मैं अभी मोबाइल से आऊँगा. आई थिंक कि पावर